Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to continue the discussion on LPWAN, Low Power Wide Area Network. This video, I would like to explain why LPWAN can transmit very low power and yet is able to cover a long-range communication easily. So this will be the objective of this video. This is my email. If you have any question regards on this discussion, please drop me an email. Okay, or if not, I actually prefer you guys to ask me your question through the comment. Before I continue, I'd like to urge you guys to help me by like this video. Guys, it's free and it's just a few seconds. Help me press the like button now. For those who are new to this channel, and if you want to support me, please consider to subscribe and turn on your notification bell. Once again, thank you so much for your strong support. Before we start, let's understand this. Low power is actually not equals to long range. When we want to achieve long range, we probably need to transmit higher power. So basically for this case, you can say that power is indirect proportional to range. But how LPWAN can in fact transmit a very long range and yet with low power? So this will be the objective of this video. In fact, there are 5 reasons why LPWAN can transmit very low power and yet able to achieve long range. Let me further explain the relationship between power and range. For example, in this case here, let's say that I want to establish communication and we actually stand side by side with each other. So in fact, I can talk gently and you are able to hear my message. So when I actually talk gently, which means that I actually use low power in order to establish communication with you. On the other hand, let's say, imagine this, you and me, we are actually further apart. So now, in order to establish communication, I cannot just talk and you probably will not be able to listen to me. So I need to shout in order to establish communication with you. So when I actually shout, this simply means that I actually utilize more power in order to establish communication with you. So basically, this is actually the relationship between power and range. So when we actually has a longer range, we need to shout. So when we actually shout, we actually use more power in order to establish communication. This disobey the protocol of LPWAN. For LPWAN, I need to talk gently with you, and yet you must be able to hear me in the long range. Why? Okay, so like I mentioned earlier on, there are 5 reasons. Reason number 1, this is actually the equation for free space path loss equation. From this equation, you can see that path loss actually has a relationship with distance and also frequency. We could not do anything on the distance, so let's focus on the frequency. So ZigBee, in fact, is another low power device that actually can establish communication with a range of 100 meters. So ZigBee typically frequency is around 2.4 GHz. So from this equation, okay, you can conclude that every 6 dB, in fact, you double the range, which means that whatever, okay, you actually reduce the frequency, you actually prolong the range. So let's say if I reduce the frequency by 2 times, I actually prolong the distance by 2 times also. So LPWAN typically use 900 megahertz. So from here, you can see that LPWAN actually has a frequency 2.5 times smaller as compared to ZigBee. So what does this actually imply? This implies that with the same transmit power of ZigBee, instead of 100 meter, it becomes 250 meter. So this is actually the first reason. They reduce the frequency in order to achieve a longer range. So this is actually the first reason why LPWAN can transmit very low power and yet able to achieve long range. Let me explain a little bit more on the reason number 1. So LPWAN typically use sub-GHz. Okay, sub-GHz simply means that less than 1 GHz. For example, 433 MHz probably used in China, 868 MHz used in Europe, and 915 in US. because of lower frequency. Okay, we know that lower frequency, in fact, they can actually propagate further because of the free space path loss equation, and also because of lower frequency, they are able to penetrate through buildings and obstacle better as compared to the higher frequency. This, in fact, allowed the signal to travel kilometer in urban area and probably tens of kilometer in a rural area. So basically, this is actually the first reason. Next, my second, in fact, also my third and the fourth reason why LPWAN is able to transmit very low power and yet is able to reach long range. This is actually the equation for receiver sensitivity. What is actually receiver sensitivity? The definition of receiver sensitivity is actually over here. Receiver sensitivity is the lowest power level at which the receiver can detect an RF signal and decode the data. Sensitivity is purely a receiver specification and is independent of the transmitter. So in short, the smaller the number, the better the radio, because you can actually receive a very weak signal. So ideally, we want this receiver sensitivity to be as small as possible. So what if I can remove away these three terms? So ideal, because having a receiver sensitivity minus 174 dBm is ideal and is not possible in a practical world. So let's understand a little bit more on this. Since LPWAN has low data rate simply means that it don't require a high bandwidth to carry the data. Hence, the bandwidth will be very small. So basically, this term here will be very small. Remember what I mentioned earlier on, we want the receiver sensitivity to be as small as possible. So hence, with low data rate, we in fact can make the bandwidth smaller. Hence, this term will be smaller. So basically, this is the second reason why LPWAN can send very low power and yet reach long range. Let me again focus on the second reason. Low data rate in order to achieve better sensitivity. LPWAN device often send data at a very low bit rate, okay, which means that they carry only very little information. So with low data rate, this simply means that the receiver in fact can detect a weaker signal and hence able to extend the range. This is because lower rate of signal, they in fact can tolerate more noise, hence improve the link budget. So basically from this diagram, you can see that with lower data rate, in fact, you can see that the receiver sensitivity value also go down. So this is actually the second reason why LPWAN send a very low power and able to achieve a long range. Before I continue the discussion on reason 3, 4, and 5, I need your help, guys. Please help me by like this video. When more you guys actually help me to like this video will have a better chances to reach out to a larger audience. So guys, help me. Press the like button now. If you have learned something from this video, urge you to help me by subscribing to this channel and turn on your notification bell. Once again, thank you so much for strong support. My third reason, okay, remember I mentioned earlier on, we want all these numbers to be as small as possible. So noise figure, in fact, is a function of bandwidth. Okay, so when bandwidth is small, okay, the noise figure will be small. Imagine this, if you are going to have a wide bandwidth, technically you will have more noise. But when you're going to have a very narrow band, your noise will be significantly reduced. So this is actually reason number 3. With a low bandwidth, the noise figure will be small and hence this overall number will be also small. Let's study the reason number 3 in more detail. Okay, so many LPWAN technology use either the narrow band or spread spectrum. Narrow band, for example, for MBLT and also for Sigfox, they mainly concentrate the energy in a very tiny, narrow frequency band. Hence, they actually improve the signal to noise ratio. As for LoRa, actually use this Church spread spectrum. So they actually spread a signal across a wide frequency range, but encoded it in a way that increase the robustness to interference and distance. So basically, this is actually the reason number 3. Okay, they actually reduce the bandwidth in order to accumulate longer range. Coming to my 4th reason, okay, let me use LoRa as LPWAN. So LoRa, in fact, use spread spectrum. So when they actually use this spread factor chart, okay, the signal to noise ratio is actually equals to minus 20 dB. What does this actually imply? This implies that they are able to decode the message 20 dB under the noise power. So this is actually the reason number 4 why LPWAN is transmit very low power and yet able to reach long range. Let's study reason number 4 a little bit more. Adaptive data rates and network design. For example, networks, in fact, they can adjust spread factor for LoRa, or they can also adjust transmit power or even frequency in a very dynamic based on the distance and interference. Gateway, okay, or also known as base station, they are highly elevated and in fact very powerful. This further extend the coverage. Also, another reason is multiple gateway can in fact cover a larger area. Hence, this actually improve the reliability without increasing the device power. So this is reason number 4. My last reason, reason number 5. We could not increase the transmission power in order to reach long range. So what we can do is we reduce the modulation rate. When we actually reduce the modulation rate, we are able to put more energy into a bit before transmission. This in fact increase the energy per bit, which result in a longer range. Let's take a closer look on reason number 5. Simple modulation and smaller payload. LPWAN device often send very tiny payload, so therefore the size can be even like a few bytes. With lesser data bits, this simply means less transmission time and also less chance of error, hence it will increase the range. Next, in terms of low power consumption, okay, LPWAN device in fact transmit short, infrequent packet and spend most of the time sleeping. Hence, they are able to conserve the battery. Because they don't need high throughput, energy efficiency is maximized. This in fact allows very small battery to last for years while still reaching long distance. So these are the 5 reasons why LPWAN is able to transmit very low power and yet able to achieve long range. With this, I'd like to end my discussion. Please help me to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.